Today, we're going to dive into how we actually take all of this information we've been gathering through these series of 4 courses and then use them to actually communicate with the business about that. So, at the beginning, we showed you the overall flow of how all of these things tied together as a product to help automate the process of moving the models through your business. But, then in the next class, we looked at how we actually enable models and then how we built life cycles as part of that, as part of the process, and all of the different details and intricacies within those things. But there's not a lot of value in doing all of that if you can't tie it all together and communicate it to your business as well. So that's what we're going to be going through today, is how we can actually leverage that information to help communicate the progress to your business. So this will be the final series on that. But I want to remind you again, I like to start out. We're going to do a few slides today to talk about what we're actually trying to accomplish here, as well as a reminder of some of the data models that we're going to be using. And then we're going to dive directly into a hands-on portion again, where we'll actually utilize the product to develop some reports on that. So you can see what today we're primarily going to be doing is we're going to be using Tableau as a BI tool for actually doing the reporting. And we'll talk more about that in a minute. It utilizes web data connectors to communicate through to our micro on there that actually have been storing all the information about the models as we've developed and deployed and moved them through those various life cycles and gathered information through them about the process. So we'll be pulling information primarily from Model Manager on there and that kind of things, but also some of the information that was developed from Model Lifecycle as it actually drove and automated tests and things like that. And so we'll be leveraging that information as well. Model KPI types. That's what we're really talking about. What different KPIs you can actually develop within your business for measuring models. Now, there's really 2 different kinds we're going to discuss today that are kind of 2 major categories. There's one where we actually kind of want to understand about the nature of all of the models in the business, not anything specific about one model, but what is going on out there in the develop, like what kinds of models are actually being developed, what technologies are people using, et cetera, that kind of thing. So that's important to know is where your company is making investments and also progression. For example, today we're going to look at migration of Python files to Python 3. Python 2 is no longer supported. We need to track how many models still haven't necessarily been migrated and that kind of thing. So we can get some of those kinds of insights at a really high level about all of the models, that single pane of glass across all of them. And also a little bit about, across all of the models, how many are making it from the beginning of maybe just playing around with it to actually getting out to business, and how long is that taking and things like that. We want to know that kind of information, not specifically about any model, but across all of the models within my organization. And finally, what are the impacts of these models within your runtime environments? How much CPU are you using up and things like that? How long are these processes taking? Should there be concerns? We see growing trends, lessening trends, et cetera. Again, so there's this whole category about just models treated generically across the entire business and what kinds of impacts, et cetera, are they actually having on our system. And then there's more specifically individual models themselves serving a business role. So what impact is that actually having on the bottom line on your business? We're going to use an example. It's not going to be a real world example because we can't share that kind of information, but one that's use the simulated values. And the idea is, real dollar impact, that can often be measured on a model. Excuse me. Now, these are actually not measured necessarily just on a model by model basis, although that's how we'll be looking at today, but it can also be a model role. So like a substitute model that's been put in or that kind of thing, in that they would share that same metric probably across all of the different ones. So we want to know which models are costing us money, what do we need to give attention to, real world impact, if we better invest in improving this model because it's costing us this many dollars on that kind of things to keep it in sight. And then also being able to then do comparisons between models and see which one actually over time would be delivering us better business value as well, and how do we actually track that and leverage the model lifecycle service to actually do that in a consistent manner on that kind of things. And then we also just need to have that clear understanding of those predictions and how they actually impact the business overall and that kind of thing. So we'll have that. So we'll be doing those kinds of KPIs too. As you can see, they're two very, very different categories, but they both provide valuable business insight in different areas that we want to examine on that. So when we looked at how to actually track all these KPIs and do that, we've invested heavily in making sure that we have all of the data there to do that and more. We have tons of different data models and things like that that capture that and make sure we can tie it all together and automate that process of that data collection and actually bring that value and make the things available through there. Then additionally, when we looked at doing reports about generating KPIs and stuff, we can have some generic items that can provide that kind of business value and provide some insight. But what we really realized is that they're kind of limited in what they can provide for your business. So for instance, we very definitely every model is going to have a different cost for degradation and in performance. You may have an entire different way that you actually want to look at models and how they tie to your business value. Business value isn't necessarily just about dollars. It could be customer satisfaction. It can be the increase in traffic to your website, which ultimately can translate to dollars, to be honest there. But that's not necessarily what you want to report on initially on that kind of thing. So when we looked at that, we realized we can provide definitely some high-level views that are consistent across organizations, but we really needed to make a decision on how we would go out and interact with business BI tools to actually provide your ability to not only create the customized reports that you need, but also be able to share them across your organization and also allow other people to collaborate on those reports and also make sure that they can be readily and quickly updated to maintain relevance as to the time and not be honest. To try to build all of that ourselves in a way that would scale just didn't seem like the wisest investment decision. So instead, we chose to actually develop the solution that you're going to see today, which is to integrate with various BI tools. In specific, we're going to be looking at our first integration there, which is with Tableau, because it's a great tool for being able to quickly design reports. There's a lot of resources out there that know how to use Tableau, and it does provide connectivity methodology to external data sources, and in specific through what they call web data connectors. And we'll go over the architecture of how that works in a second. So, really, it's well designed for that. And basically what we've done is by default, within our solution, we just embed the web data connector right in our solution. We'll show where that fits in a second. So that way you can immediately connect out of the box with standard Tableau. We'll just be using the Tableau public version today, where you don't have to go and install anything in Tableau or anything like that to actually leverage what we have there. Once you have that up and running, you can just use standard Tableau to gather data from our services on that kind of thing. What we'll be showing you today is the first version of it. We're still constantly adding new features to it on that kind of thing. So we have some of the data exposed today through that, but some data is not yet exposed, and we'll be having more options and improving that constantly as we go along. In specific, how Tableau web data connectors actually work. What we actually do is we implement a web page that provides the ability to provide basically the input to our system to get the specific data you're looking for. Today we'll be concentrating around model test results and model definition information, as well as jobs associated with models. So in specific, we'll be doing that. So we'll be specifying that kind of information on there. But basically, it also utilizes the JavaScript to translate to it. So basically, we've implemented JavaScript that translates from the JSON structures that that our microservices provide, and puts it into a Tableau tabular format. That's a little hard to say both together like that, where we actually basically have to flatten the results because Tableau doesn't really support native JSON in that way. It more looks at individual values. And we also have to scrub some of the complex values that are more object-oriented because it doesn't work well in a tool like that. And, we're going to be exposing more values as we identify their usefulness on that kind of things. In specific, when we get to the scores, for instance, we do support dynamic methodologies of doing that. We'll talk about that a little bit more in a minute as well. But basically, once we have this all in here, we actually have the kind of the two-way communication between Tableau and ModelOp Center. So you can fully interact live with ModelOp Center directly from within Tableau. This isn't, excuse me, like an export where you run it once and get a CSV file and have to then manually import it into there. This is actually full interactive, fully from within Tableau. So we'll actually be doing everything from within Tableau today in our hands-on demonstration of this here. So one of the reasons we do that is basically we can pass the parameters directly from Tableau into our web data connector, so we can do that live filtering of the information you want on there. On that kind of thing. So today we're going to not be filtering by date and everything because we have very minimal data installed in the demonstration cluster we're going to be using. Things like dates and ranges and stuff, so that way they can be shared. But then also when you go to share that report with somebody else, if they want to actually interact with the data and create additional reports themselves, they can live refresh that information as well using the parameters you specified, so they have full access to that information as well. And then finally, the full Tableau functionality is available with live ModelOps Center when we do this. So it really lets you use full Tableau, do joins and all kinds of things. And we'll be showing that, how we actually set up some joins between multiple tables so you can pull that information together as well to create sophisticated reports on that kind of thing. So, I should point out, I forgot to mention on there, since it's using the Spring Cloud Gateway and it's using the web-based interface, all the OAuth 2 and authentication and such that we do natively is fully supported as well. So it's secured in that methodology. So before we jump into the live demonstration of it, I want to quickly remind people about some of these tables we're going to be interacting with today. Now, in our system, they're RESTful interfaces that return full JSON objects. They're going to be represented as a flattened view within Tableau, as I mentioned earlier. So I want to kind of point out some of the different tables we're going to be dealing with a little bit here, and of course we'll refresh as we go through the live data and actually interact with them. But the terms are important to make sense of some of the metrics we're going to be kind of trying to put together today. So first of all, we have the stored models. Stored models are really the kind of importation of those models from the various model factories or Git or other resources where we kind of gather that information about the metadata, all the assets that are associated with the model, any references to it, platform-specific data. There's a ton of data there. Now, for the purposes of Tableau, we're only extracting a small amount of that data because a lot of it is too complex for tabular form. But we've extracted some key items that we believe are useful, and we'll continue to expand upon that as we do that. But the key thing about stored models to remember is they are an up to the second representation of basically the model. So it's not a version of the model. It's literally, it could change at any time. So when you reference those, they're referencing really truly the in flight as it's being developed. And then at some point, as you remember when we were doing the Jupyter presentation where we were going through and actually submitting the model, what we were saying, yeah, this model is now a versioned entity. And that's what we refer to as a deployable model. It means all the pieces are there. This is defined. It can be used. It can have jobs run on it. It's a complete snapshot of a stored model at an instance of time that's considered complete. So the reason we do that is we want to always be able to get back to the information of the second that job or deployment occurred of what the model state was. So we have all the Git IDs, for instance, so we know the exact references within Git where we can pull those assets from on that. So, you know, as I said, this is kind of our abstraction of a model version on that kind of thing, but it encompasses more than if we just put like a 1.1 that doesn't provide you a lot of information. This will literally be a full snapshot of all the metadata, all the Git IDs, everything at that second in time. So we can think of that as a usable model that's a published version of it. Then finally, at some point, when you actually want to deploy the model in business, at an endpoint where it's running and making real-time business decisions on that kind of thing, it's now become promoted to a deployed model, where that is going to also contain a reference to the deployable model, because that's a static, immutable snapshot of the model in time. But it's also going to contain the full lineage of the life cycle. Just remember when we walked through the day in the life scenario where we ran through the full life cycle of the little mini one we do. At the end, it was ultimately deployed, and we could go back to that deployment and look at it and see how it got here. That's the difference between a deployed model and a deployable model, is that the deployed model also contains all that lineage information and the reference to the process, the model lifecycle it took to get there, and also all the references to the individual tickets that were there as well. So we have all that kind of information. And the final item we're also going to look at today is, if you remember, we actually, as part of the model lifecycle in the demonstration, we actually ran some automated tests on the model on check-in and used the comparator. We also had a back test running constantly, where it's running on new data. Now, we're going to have some test results that are a monthly run, which would be more reasonable back test, where we're looking at the model performance and new data over time. So we're going to have these model test results, which are basically parsed out of these batch runs that occur using a deployable model. And just a reminder on the metrics on those, they can be any name value pairs. We're going to use some very common ones today, like F2 and things like that, but they could be customized scores and everything, and they will be visible and accessible. We dynamically populate those within Tableau, so they will appear based on the models that you have on that kind of thing. So with that, we're going to get out of the slideware for a little bit here and actually jump into Tableau and provide some demonstrations of how we bring the data in first. And then after we do that, we're going to kind of connect up the tables and do some joins there and things like that. But then we're actually going to build some visualizations using that table. Now, I'm not the best Tableau artist in the world, so we're going to be doing some really simple tables and stuff like that. I'm sure there's many of you out there who are probably more artistic and better inclined with it than I am. I'm more of an engineer, so I just use the raw charts. But, you know, we get the idea of how you can put these together into a report and actually represent the state of models across your entire enterprise, as well as looking at the individual role we talked about earlier as well, where we examine the cost of business of model degradation over time, and how we can actually leverage the data we have automatically generated within ModelOp Center to do that. So with that, we'll get out of the slideware and we'll jump into the Tableau product here. So let me bring up Tableau here real quick. Okay, so it's just the standard Tableau public we'll be utilizing today. So this is off the shelf. We haven't installed anything in it in specific, so it's that easy to get up and running with it. You can see they have connections to a server for a web data connector, and that's what we're going to be using today to connect to ModelOps. So we bring that up, it's actually going to ask us for our address. So this would, we're running off of our local Kubernetes cluster today. So we're just going to our local host, but what you'd really do is go to your ModelOps installation. So we'll just type in the address of our web data connector, and then it'll actually connect through our Spring Cloud Gateway services here, and basically allow us the opportunity to grab the test data and other associated data with that. As I said, we have some other options as well, but we're gonna start with test data today for doing that. We're going to specific grab our XGBoost model that we actually used in the last demonstration, where we showed it failing a back test because of model degradation. Well, that was a point in time in alerting someone. Instead, we're going to actually look at the trends today of what was going on with that model and what that was costing us over time, so people can get that. So we can go ahead and actually get the data directly in there, and it'll actually go up and talk. And you can see now we have a series of tables that are actually have come directly from ModelOp Center that we can interact with. So as I said, the focus today is going to be around these test results for this XGBoost model. So we're going to go ahead and bring that one in to start with. We can see the actual scores that this particular model is reporting, and we're going to go ahead and actually bring those values in so we can examine them. And you can see we've got some linkages to the different versions of the model. We talked about the stored model that's still being updated live, and the deployable model that actually is a static version in time, so we can reference that stuff, as well as the individual scores that this one particularly reported. There's things like ROC curve and stuff that it actually reported as well, but those do not translate well into Tableau, and I'm still looking at the best way of doing that so we can bring in that kind of subtable information as well on that. And then we've added a column. Now, I did this just for the point of the demonstration. This would typically not be stored with the model. It's probably going to be coming from a SQL database or somewhere else about what is the cost of degradation. Now, this particular model is actually a model that is predicting basically the chance of insider trading based on emails. So we chose to specifically use F2 score because the cost of a missing one is potentially very, very high. So we want to bias the results towards making sure we don't miss one at the expense of basically, you know, yeah, we're gonna probably identify too many when we should do less. So we purposely chosen that score for this particular model. That's something that the data scientist and the business are going to need to work together on to determine which score should be used, and then try their best to figure out the business value of that. You know, it's always a balance of precision versus recall, and how do we actually go out and determine which we way to. It said, you know, in this particular case, we want to bias towards, you know, that recall to make sure we don't miss any. And then it's a little bit of black magic to then figure out your dollar cost per that, if that's the appropriate way, or maybe you have some other metric on that. And that is something you're just going to have to figure out on that kind of things on a per business role basis. Because I'm not aware of any magical way of doing that because every business is different. So we've stuck that as actually self-reported by the model, our estimated cost in tens of thousands per change in F2 point. And basically, you know, that's where we put it for now. In reality, this would be in a central store somewhere, but for the sake of demonstration, this is easier. So we're going to go ahead and also bring in basically, excuse me, the deployable models that actually were utilized for this. And you see we can link these up. So we know we have basically a deployed model ID, and basically deployable models has the ID as well. So we can do that. And now these two are actually linked, so we can bring that information in and get the items on that. As mentioned before, we also have the deployed models we can bring in here on that kind of things that reference basically the deployable model. And you'll see that they actually have the deployable model ID as well, so we can link those up and bring those in and get that. We actually only have one deployed model in this demo system. Finally, we can actually bring in model jobs as well that basically utilize deployable models. So we can see the idea of the deployable models, and once again, link it up to deployed model IDs. So, you know, we can build up all of these basically these individual items. And then, you know, we even have the, I got the deployed, deployable, and that, and stored models. There we go. We can even link that back if we want to the original items, because we have the stored model ID, and then we'll get the ID as well. So that way we can get more details about the individual items that are in there, and you can see we can that as well. And we have quite a few more stored models in than we've actually done for the test results. So you can see how we can build all these together and pull that data, and we just got that live right out of the ModelOp Center, right from Tableau. So there's nothing magical to do there. It's pretty easy on that. Well, let's take a real example of looking at something from the the highest level, the single pane of glass across the whole organization. I mentioned earlier, we want to know what technologies we're using to actually develop models. So let's look at that stored models. We have the model type. So we're going to go ahead and actually bring that into our sheet. And we're going to look at, change our sheet to model technology. Right into our sheet. And we're going to go ahead and rename that. Now we've got the model type. But what we really want to do is we just want to kind of get an overall. So we're going to add in a count of model type. There we go. In stored models. And I think I got one more paren on there. And when we bring that in now, we can rapidly start to manipulate those. Now really what we're going to want for our little report about all this, we're going to turn that into a pie chart and try to make that a little bit bigger here. And then we can also add in, for instance, we can go and grab that model type and make that a label for here too. So in a couple minutes, we've quickly been able to put together basically a simple view of what we're out there. And we can see, yeah, good, our Python 3 models, they're starting to increase that. Over the Python models, we have less of those Python 2 models there, and we have more of the Python 3. So as an organization, we're making great progress there on that kind of things as well. So let's look at something else as well in the results here to actually build up our report. So what kind of impact are we having on our systems across there? What's our run times on our average jobs? So we're gonna go ahead and look at just name this one like average total execution time. So again, we're looking at across the entire organization rather than a specific model this time. We want to grab that. So we're going to take a look at our model jobs. We're going to grab that created item. Oops, up there. Let me hide that so it's not blocking me. There we go. We're going to grab our created item out here. And we're actually going to go down. Let's take this demo because when I set this all up, it obviously ran all pretty close. So we're going to go down to the second just to get some granularity here on that kind of thing. And then we're basically going to look at what we really want to do is look at a row. We're going to do a calculation here. So what we want to look at is the job. These times you see as columns here are actually real seconds since the epoch. So milliseconds since the epoch. So it basically allows us to get the difference on there. So we're going to look at basically the job end time. And we're going to subtract from that the time it went into waiting. So there's when it actually scheduled up because we want to know the full time that job actually took to run. We could also look at the actual start time as well if we wanted to, when it started running, if we wanted to know just the actual execution time. But I want to know how long our job's actually doing overall. So we're going to just subtract the end time, the wait time from the end time. And that's going to give us the average time in seconds. So, we could just change our label really quick to execution time. So we can go ahead and do that. And now we have a nice little graph just showing us, and again, we're using time. This could be by month or day or year, or any of that. And that's the whole idea of using this, where we can see on average how much time we're actually executing all of these individual jobs that are out there on that kind of thing. So that gives us some idea. So that gives us another item we can add to our report. And obviously, is that I'm not the prettiest in the world. So these are real simple, but you can dress these up with Tableau as much as you want to really have that visual impact across your organization and continue to update them on that kind of an item as well. So now I'm going to create another sheet here, and we can do things. For instance, we're going to actually look at, we can look at the different kinds of deployable model, the different state of the models. Are they moving through the business or not? So we're going to go out and basically, again, go add an item here, and we'll go down, again, just for the sake of things, we'll go down to the second here. We're just going to go on the created date. And now what we're going to do is add a few columns. So we're going to add a count of ID of we're going to look at first at the actual stored model. So the total number of models we have across the system created at those various time periods as one of the items. And then we're also going to look at, we can look at the total number of basically deployable models. So how many have actually progressed on to the version, so to speak, of those items. And then we can also look at finally how many have actually made it out into kind of ID, how many have actually made it out into business. So yeah, we've got ones that are version that are waiting, but how many have actually made it out into business. And we're going to want to represent that as kind of a stacked item. So here we can see we had quite a few models that have been created, but not a lot are making it out into the business. We only had one that made it out of the business. That's because this is the demo setup. And we can see that there's several different items that are kind of waiting to actually make it out of there, as well as a new stored model that was added out there. But so this chart's not that impressive because we don't have tons of models installed yet. And then you can get the idea of how we can get a current kind of high-level view of overall where are the models within our system. So now we have that done as well on that. And finally, we want to talk about that kind of in-business models and what impact is it having in our system. So again, we're going to go ahead and grab this time from the model tests. We've got our parse model test results. We're going to grab that created again on that. And this time, we've actually staggered these by month of what data they were actually processing. So we're going to bring in the day column to actually do that. And then what we're going to do is actually bring in that F2 score we talked about. So we're going to bring that right into here so we can look at the F2 over time of that. So rather than just that, if you remember right from the demo, we hit below that 6 threshold, that's 5.2 here. We can see that it's been degrading before that over time and didn't just finally took a big dip and kind of crossed that line. But then what we finally want to do is actually look at the actual costs. We want to throw that metrics in here too. So this one's a little complex, so deal with me as I do that one. I might get this backwards initially. I've been known to do that. So we're going to look up the previous value, which could be null, so we have to check for null on this. And put that there. And then we're going to get the sum of F2. And then we're going to look back, and this is where it gets a little tricky in their editor sometimes. We're going to look at back one entry. See, I think I'm missing one paren there. We got the ZN sum, there we go, comma, -1. So we're going to basically look back at the previous entry. And we're going to subtract from that the basically the current sum of F2. And that should give us a change, and I think I did it the correct way. Yep, okay. So now we've got the change in F2, but what we really want on this is we want to actually look at the dollar value. So first of all, we need to turn it into points. So we're going to add a multiplication by 100 to get the number of points of change. And no, I think I did get it backwards because it's negative. So let me switch that around, or did I miss a paren? Yeah, I think I missed a paren. Let me get that on there. There we go. Yeah, I just missed a paren. So now we've got the basically the number of points of change. But what we really want is dollars, because that's going to communicate better to the industry. So we're going to do times that cost, that sum of cost for F2 points. So that column has said that we would actually get from somewhere else. So now we have it in the tens of thousands of dollars, and that we're actually going to change that label to make it more useful of 10K cost in 10K dollars. Make some more sense. It makes some more sense there. And really, the way we want to view this, that I would choose to do it, is kind of a combination here, where we're going to we're going to change the F2 to the line, and we're going to change this one to the bar. Now we can get an idea here of basically our cost as it relates to the F2, and we can see it's really spiking here as we get out here. So this is a net loss to the business on that. And we can see the impact it's actually having And, we can call that our, cost of ecom performance, something like that. So we can basically call that out instead. So that. Then finally, we can kind of put all these together. So, we can create ourselves an actual dashboard where, maybe we're talking about the overall level of the models here and what they're doing. So, we're talking about the impact in the business of the different technologies we've chosen. And then we could throw another report together where we're looking at overall in the business, where are my models at? And, specifically related to ecom, here's all the models that we've got in flight related to this, and here's our current costs of our current deployments. You can see how you can rapidly kind of develop these reports. So these are messy and quick. We can make much nicer ones, and there's people more sophisticated in Tableau than myself, but you can see how we can pull this this data directly out of Model Manage and actually update it or refresh it at any time and pull it together and have this full range of information together so that we can actually develop these live reports that get updated and have consistent workbooks that do that, and then be able to share this across the business to communicate what's really going on with all of our models, with the different types of models we have, and also the ultimate business impact of what's going on with these models, and the integration of the power between Tableau and the ModelOp Center, and that all of this here is actually automatically just being calculated in the background. We're running those tests regularly and can update these reports and stuff, and we can trace that these reports ran, and we know what model is actually causing this kind of degradation in performance. We can go fix it and notify people and make sure they do it. So I hope you've seen through all these 5 classes how we're doing everything from picking up where the model factories end and really managing these resources across all of your process, all of your business processes that need to occur. Reports need to be generated, items need to be sent out there, et cetera. And then ultimately, we're gathering all that information together, ensuring the quality of the models are getting out of there, and then ultimately being able to, at the very end, create these kinds of reports that actually you can present about what is going on with the models and the impacts you're having. Because we show the net cost here, hopefully, by using these processes and things like that, we can show actually the savings to the business as well, where, you've done these improvements, we've moved through, we're getting them out there more rapidly, and in the end, we're actually delivering real business value. And that's what needs to occur with models at the end of the day. So with that, I thank you for seeing through these with 5 different classes we've done here together. I hope they provide you a lot of insight into what we do. And with that, Linda, see if there's any questions in the last few minutes.